Hello everyone, so in this video let us talk about a problem from LeetCode. It's an easy problem. The problem name is same tree. So let's read the problem statement first. You are given the root of two binary trees P and Q, and you have to write down a function which will just check that both of the trees are same or not. Now you just have to check that. By same it means that they have the same structure as well as the value on the nodes are also same. That's the overall problem statement. Now let us take an example to understand that. But the overall logic here is just take two pointers starting from the root node of both of the trees and try to move both of these pointers simultaneously. Like if one move left, take the other move on the left hand side. And that's it. Now the observation at each point is that at every point, the value of the node on which you're iterating on both of the trees should be same. And if let's say a node exists in one of the trees and not in the other tree, that case is false. And you just have to check both of the conditions. So let's take an example, small example, so that it will become more clear to you. So what you will do is that you will draw a node here. Let's say a tree is like this, the same example from the problem statement. Now what you'll do is that it is 1 2 3 1 2 3 like this. Now you will take two pointers, one pointing at the root node of the first tree, the other pointing at the root node of the second tree. Now what you will do, both of these moves along the same type. So you will first check that both the values are same on which both the pointers are upon. So this is one, which is fine. Now this move to the left hand side as well as this pointer also move to the left hand side. Now similarly, now you'll just check that both of the values are same. It is same. So you're just doing a recursive function. Now both move to the left hand side. Now this is null as well as this is null. So if both turns out to be null, like there is no pointer, then it is also fine because both of them are null. But if when you return back and let's say that maybe this value is 3, this value is 2, when you go on this side, the node exists but these values are not same, so this is false. Or let's say that there is no node at all here. If you go to the right hand side of this node, there exists a node, let's say 3, and there is no node here, so that is also false. You just have to take care of these three conditions. The node exists on the left hand side, the node exists on the right hand side if like on both of the trees, or else if the node exists in both the trees, then they have the same value. If this is the case of which the condition turns out to be false and the trees are not same, else for every case you just iterate over the tree and just find out whether the answer is true. If both of the values, let's say this value and this value are same, then you just have to check that the left hand side of the tree and the right hand side of the tree are same as well. So you just call the recursive function again on the left hand half and the right hand side half, and that's it. So let's move on to the code part so that it will become more clear to you. So this is the actual function. So whenever we have talked about the recursive functions, it has the base condition first. So the base conditions are actually these are for which we know the answer. So if the P and Q nodes on which we are using to iterate over both of the trees are null pointers, both of them are null pointers, the answer is true because that is fine. If any one of them is null pointer, okay, then the answer is false, because which means that one is findable, one node exists in the same half but the other doesn't exist. That is why if any one of them exists, then it is false. If both of them are null, that is fine. But if the both of them exist, then the value should be same. If the value is not same when both of them exist, then the answer is false. If both exist, value same, everything is fine, then what you'll do, you call this recursive function again on the left hand half of the tree as well as on the right hand half of the tree of both of the trees which we have. So we just call the same tree function in which now we move to the left side of this P tree and the Q tree. That is why it is moving simultaneously. Similarly on the right hand side of the P tree and the Q tree. Okay, so this function is now recursively called on both the trees half, that is right half and left half, and both the half should be same as well. And then when both of the functions return true as well, then you just do an AND operation and just return the answer. That's the whole case, and we are just doing an O of n operation to just iterate over every tree, just doing an O of n operation to iterate over this whole tree. So that's the overall time complexity as well for this problem. That's the overall case of this problem as well. If you still have any doubts, you can mention down in the comment box. Thank you for watching this video till the end. I will see you next one. Till keep coding and bye.